Good morning, students. In today's digital electronic class, we are going to see the problems related to Vhdl code. That is a left out topic we have not done in the unit 3. That topic I'll do it, and some parts which we left with the parts which are important for examination point of view. Those topics we are going to cover. So let us see. So the concepts what we are learning in today's classes. Vhdl code for decoder. Okay, so this we have not done. So basically we know that what is a decoder? Decoder is a device which converts the n inputs into 2 power n number of outputs. So let us consider one example. 2 to 4 line decoder. Right? What is a 2 to 4 line decoder is going to perform? It's going to take if you want to write the gates for it. So 2 to 4 line decoders means it should have the outputs of how many? There should be 4 outputs and inputs needs to be 2, right? So based upon that, you need to design the 2 to 4 line decoder. Decoding of the sequence that can be done, n inputs can be converted into 2 per number of outputs. So here is what 2 inputs is there. It is going to convert into 4 outputs. So suppose I'm just want to write the decoder block of it. So we are giving 2 inputs. Suppose inputs is A. Another input is B. Next output is getting 4. So D0, D1, D2 and D3. These are our outputs. So this is what 2 to 4 line decoder. In order to do that, we have to give one enable. Enable inputs we are giving one extra to design it. So now I'm designing this 2 to 4 line decoder by using Nand gate. Using Nand gate. So how do we design it? I'll write Nand gates. Right? So what is the first output needs to be? D0. Next is D1, D2, D3. So these are our outputs. So what are the inputs value we're giving? We're giving A not of A. So this is A, this is your A bar. B with not of B. And enable we are giving so as to get the exact one. Right? Enable E. This is E complement. So just want to get D0. So it's what? Should pass from all the values. And complement also. This is what enable. This is not required. 2 input is enough for designing, but enable is used to just make that combination circuitry of decoder to be in a proper designing. For that particular thing we are giving enable, or else you can skip the enable. No issue with that. We can take A and B 2 inputs and we can design with that. Okay. So now D1 will be 0 and it needs to be 1. So B should be taken from 1 and always will give bar to it. Okay, how it is going to work I'll tell you with truth table also. Next one D2. D2 means 1 0. This is 1, this is your 0, right? Similarly 1 1. D3 means 1 1. So taken from D3, this is 1. So this is also 1. So what about enables here? Enable 2 I am giving 0 and remaining 2 I am giving 1. So suppose I am giving enable here 1. Here also enable is 1. Okay, so this is what we have did. We designed the 2 to 4 line decoder by giving the number of inputs. So in this what I did, I gave an inputs based upon the values what I do have. So based on that this I got it, right? So 2 to 4 line decoder, only 2 input is required. We are giving one enable so that you should know if they gave enable in the question to design, you can able to design it. Now let us see how the truth table is going to work for this particular Nand gate. You can design by using any gate. So universal gates is acceptable everywhere. That's the reason I'm just proceeding with this particular gates. Now proceed with the next. How do we write the code for it? Before writing the code, we should know the truth table. So truth table means what? How the operation is going to be there for these particular 2 inputs. If the 2 input is given, with this part and the particular gates of it, how it is going to operate. So for that thing we have to write the NAND gate operation, means truth table for it. So NAND gate, if you are designing by using NAND gate, what are the things you gave? You gave enable, you gave AB to inputs, right? What are the outputs? D0, D1, D2, D3. Suppose enable is 1, these two are don't care. Means you don't want A and B. If enable is 1, all will be 1. If enable is 0, this is 0, 0. Means D0 should be 0. Remaining is high. It's reverse operation. The previous one, what we have seen, normal gates. Since we are using the NAND gates, so it will work like a reverse one. So suppose enable is again 0. So what is 0, 0 means? Next is 0, 1. 0, 1 means which gate? D1 should be 0. Remaining should be 1. If it is enable 0, this is your 1, 0. A 1, 0 means 2. So D2 should be 0. Remaining should be 1. Likewise, if enable is 0, if both are 1, 1, then all should be 1 and D0 should be 0. Reverse. So it's work like a active low. For 0, it will be going to operate it. So that's how it is get operation. Now we need to write its Vhdl code. So before doing that Vhdl code, what you need to understand? You need to understand the logic diagram, then the truth table. After knowing the truth table, what we can write? We can write the Vhdl code for that particular sequence. So since I said it is going to work for active low. Active low means if bits are lower, then it's going to work. If bits are higher, it is going to skip. Clear? So this is the way this particular NAND gate is going to work. So if enables are 0, for all condition enable is 0, for all the values enables needs to be 0. So in the designing also we have to use as per that particular situation. Means wherever enable is there, enable needs to be 0 for all. So this is C, enable is 0. Here what is the output for this? A bar, B bar, enable bar. For this A bar, B and enable bar. So enable bar, A bar, B. Okay. Now for this, what is D2? D2 I can write. So D2 is what? A, B bar and enable bar. A, B bar and enable bar. Next thing, for the next one, last one, AB and enable bar. For this, we should give the connection from enable bar itself. For this also enable bar. Okay, so this is that we got it by using the NAND gate operation. Now we'll try to write its Vhdl code. So let us see, students, how do we write the Vhdl code. So basically how many inputs we do have? We need to write the array as well for that particular sequence, because here outputs are varying from D0 to D3. So that particular thing, first to design the Vhdl code, we are well aware of it. What is the things we know? We know that for designing the Vhdl code, we must design the module and we should give the name for the module, and what are the outputs we had, and what are the inputs value. Okay, so output also we need to write, and input values also we have to write it down. So first thing is what? Module. Starting of the module. So module. Next I'm giving, it's what? 2 to 8 line, 2 to 4 line decoder. This is my user defined name. Okay, bracket. What is output? D. All are D, right? Inputs are A, B and enable, right? That we wrote it. Now output. Output is an array, right? Output is an array of 0 to 3, right? So what is a 0 to 3 array? It's D. So this is the way we'll write output, because it's an array. So arrays are what? D0 to D3. So that would be written in the form of 0 to 3. 0 asterisk 3. 0 is to 3, like that we'll write. We got the output. Now what are the input values? Input, what are the input names? A, B and enable, right? So do we are using any wires? You can write the wires also if you want to design it. So or else you can write directly. So not how many NOT gates we had? So NOT. First NOT gate is for A. So NOT of, what is the output? For the first one we can write A complement with A. For this particular thing we need to write NOT of G1, negation of A with A. second NOT gate, NOT of G2, negation of B with B is the input, NOT of G3, negation of enable, right, with input is E, right? NOT gate is done. Now we had a NAND gates. So how many NAND gates we had? 1, 2, 3, 4. 4 NAND gates is there. So NAND gate. So give some name, other name G4. With that condition, for another NAND gate, NAND of G5 with another one for NAND of G6. These are user defined, right? We are defining our particular gates. So NAND of G7 with that one. Then we design NAND gates and everything, and next is what? AND module will terminate the module. So this is the way, just a brief codes of it. So now inputs you can assign and outputs you can assign. You can edit down the values for it. So we have written the NAND gates of it. Now only thing is we have to mention what are the outputs for first NAND gate. So as per the code, what is the first NAND gate? Output D of 0. For the next one, D of 1, D of 2, D of 3, right? 0, 1, 2, 3. That's the output. What are the inputs values? Inputs we have to write. So inputs are quite bigger. So little bit space is required for it. So first is A bar, B bar and enable bar. So it is what? A bar, B bar and enable bar. Right? Output followed by input we are writing. Similarly for the second one, it's A bar, B and E bar. Enable is always bar, right? Now for the next one, A, B bar and enable bar is always. So you can write negation also, you can write not. Okay, you can mention here not, all the everywhere. That is also the same meaning. So now G7, what I can write for G7? Both are A. So A comma B with negation of E or not of E. Then AND module, right? This is the way we can design with that value. So inputs we wrote it, all the gates we wrote it, and then we mentioned the Vhdl code for 2 to 4 line decoder. Okay, they can ask you this also in exam. This is important for 5 marks. Designing of the Vhdl code, which I have not said in the previous class. In today's class, I am just going to tell you how do it work. Similarly, I'll give the question to you to solve it. Design, take down the next question. I'll write it down over here. So before note it down, just take down this code. This code is important to understand. Okay, so I'll write one more question. If people try this, design 3 to 8 line decoder and write Vhdl code for it. That's the homework question. If you get any queries about this particular part, you can ask about it in the comment of the video, or else you can put your queries in the mail. Thank you. So take a brief look of the starting one, what we have discussed in that. This 2 to 8 line we done with the gate and by taking NAND gate, so the truth table is like this. Then we done with the Vhdl code. Then after that, this is the question.